So once again, we're going to turn to the next calculation to get this fully allocated dollars per unit cost. Right now we're going to be considering material costs. In the previous videos we looked at labor. So the two questions around material costs is what quantity of raw material is needed to make this product? What are all the items needed to go into it? And how much does this raw material cost? Those are the two pieces of information we need. It actually is not that difficult to find this, and you can imagine in some situations it's perfectly easy. Like if you just have parts that you're assembling, you can just say, well, what is the cost of that, and then add it all up. But sometimes in a process environment, you need to look at other issues associated with this. So we're going to go through an example as a way to look at this. But generally, the cost of a material in a per unit equation is equal to the M stands for the material cost per unit, and R is the cost of all the raw material necessary for a batch. Now a batch, if you see down below, a batch can be 1 unit or it can be multiple units, but you need to define, when you buy the raw material, like if you're making a batch of cookies, you actually make a whole bunch of cookies at once. You don't just make one cookie. So you want to calculate all of the costs associated with the raw material to make the cookies. And that's the same in a lot of manufacturing environments. You might buy a piece of metal and then you cut pieces from it. So you want to understand what is the cost of the whole batch. So in this case, we look at the cost, which is R in dollars, of the raw material. And then you might subtract from that some revenue from recycling. Now this particularly happens a lot in metal manufacturing, where a lot of the metal that's either waste or the chips from the machine, from the processing machine, anything can be recycled. A lot of recyclers buy metal from you, so you need to include this in there. Those are both in dollars, R and V are in dollars, and then the number of good units in a batch, which is N. So you can see that R minus V is going to be dollars and N is going to be units. So this thing is going to be dollars per unit. Now again, I really encourage you to think in unit analysis when you're doing a lot of this fully allocated cost calculations. I think it'll keep you straight if you consider that. Now one thing, I want to go back to the number of good units. Consider if you're cooking cookies, you make a whole batch of cookies, but maybe some of them are burnt or some of them break when you take them off of the cookie sheet. So you wouldn't be able to sell those like if you actually were selling cookies. So you need to consider the good units, because those wasted ones are not going to get you any revenue. So you want to just look at good units. So again, we're going to look at an example of this. So one of the best examples I've seen is looking at a big long piece of steel rod bar stock. So in this case it's 6 feet long and it's 1 7/16 diameter. So you want to look at this particular length of this kind of bar stock and the weight and the cost of it. Per foot it has 5.518 pounds per foot, and it costs 80 cents per pound. So when we do this calculation, our question is going to be, these are the finished product. This pin, this 1 1/8 inch pin, that is a finished product. In the processing of it, we need to hold on to the end of the bar stock with a collet grip. So this 1 inch is not available to produce any of the final product. And in addition, the saw blade itself is 1/8 of an inch. So we need to consider there's going to be 1/8 of an inch here that's going to be wasted. That'll end up in the form of chips that will be part of the recycling, if we're going to be able to recycle that. So when we consider this, we want to look at this equation again, where we have the raw material cost minus the revenue from recycling over the number of good parts. So initially we're going to step through this sort of piece by piece, but the initial assumption is that there is no revenue from recycling, that in this particular operation we can't get any revenue back from the scrapped parts. And we're also going to assume that every single part that's produced is good, that if you have a part that's 1 1/8 inch, it's going to be good. So there's no like a test or like it's not good enough, you have to reprocess it. So what we want to do is calculate R first. So R is the cost of this bar stock. So if we went to the store and we wanted to buy, I don't know, we went to Home Depot, I don't even know if they sell these bar stocks there, but if you wanted to buy them, then you would say, well, I want 6 feet, so that's what this is, And the cost is 5.58 pounds per foot, and they cost 80 cents a pound. So I just wanted to check the units. Dollar per unit, so foot is that. Pound foot, so those foots calculate, those feet calculate out. And then dollars per pound, so the pound calculates out. And so now we just have dollars left, right? Everything else is calculated out, which is what we want to do. How much did this raw material cost? So remember that equation, R needs to be in dollars. And so that's the value we're going to remember for this particular part. And also I want to make a note on when we're doing these calculations. When we think about significant figures, we keep as many as possible, especially if we're not doing everything on the computer like in Excel or your calculator. If you're transferring these like from a piece of paper to an equation. So keep as many as possible while calculating, and then at the end you round to precision of estimate. Now in this case we're going to be pretty accurate on our estimates, so we don't really need to round to that much, but initially we want to keep as many units as possible, as many significant digits as possible. Okay, so now the next thing we want to do is calculate N. So N, if we look at this is 72 inches of bar stock, right? I mean, that's how long 6 feet is, 72 inches. But there's an inch that we can't use, so that leaves us 71 inches. In addition, for every single final part that's 1 1/8 inch, we also have an additional 1/8 inch for the saw. So really, each part requires 1 1/4 inches of this bar stock to produce. So when we calculate 71 divided by 1 1/4, that ends up being 56.8 pins. But if we're looking for a whole pin, we actually can't use a 0.8 of a pin. So we round down to 56. So when we look at a 6 foot length of bar stock, we get 56 pins out of it. So now we can calculate using this equation. We know R is 26.48. We know V, in this case we're assuming it's 0. We know N is 56. So that gives us about 47 cents per pin on these bar stocks. And that's the calculations. And we could stop right there. That would be our value. But we're going to look at a couple other variations on this that we might need to consider. The first is, what if not all the pins are good? What if we have to measure them, and then in the measuring process we find that about 5% of these pins are not to tolerance? It's a scrap rate of 5%. How do we incorporate that into this process? Now, if we look at the bar stock, didn't change. The cost of the bar stock didn't change by the scrap rate. We still had to pay $26.48 for this bar stock. But what did change is now, instead of 56 units getting out, 56 pins, we actually only get 95% of 56. So if you look down here, I put 56 times 95%, which is 1 minus the scrap rate. That ends up to be 53.2 pins. So that's now the new value of the pins. My question to you will be, why don't we use 53? Why don't we round down to 53 like we did with this value? We took the 56.8 and we rounded down to 56. Why do we not round down to 53.2? Now that's going to be your question on PolyLearn. So now we have 53.2. So let's go ahead and redo this calculation now we're including a scrap rate of 5%. We have less good parts. The price is still the same. We still assume no recycling. So now we have 53.2, which caused the price actually to go up. So if we look at the previous price we calculated, it was 47 cents. But now that it's we include less good parts, instead of 56, we only have 53.2, the price actually went up. So the next thing we're going to do is consider now that we're going to look at this value of V and say that it's no longer 0. And we're going to look at what is the implications of that. So if we just look at this, we'll say, well, the raw material is going to be lower because we have revenue from recycling. So this would cause the price of the stock to go down, the dollars per unit for this material to go down, right? Because we're getting revenue from the recycling. Instead of just throwing it away, we're actually getting money for it. So let's see if that works out also. Again, we have the R of 26.48 and we have the N of 53.2. So now we need to calculate V. In order to calculate V, we need to figure out how many pounds of this is actually going into the waste bin. So the initial bar weighed, it was 6 feet long, and it's 5.518 pounds per foot, so that was 33.108 pounds. Now the good pins, the ones we got out that were good that we ended up selling, is 53.2, because that includes the scrap rate of 95%. And we had each pin weighed 1.128, and that is in inches, so we need to convert it to feet, because this value is 5.518 pounds per foot. So we're looking at all of these pins, and this is how big they are, this is how much they weigh. So that means we have 27.521 of good pins. We take the difference of that, that means that 5.587 pounds are in the recycling bin. This includes the bad stuff, this includes the chips, this includes the collet grip, all of that is included. So what end up being that if we take that 5.587 pounds and we multiply it by 10 cents a pound, which is what we know the recyclers pay us, we get about 56 cents for every bar stock back. We're going to include that now into this calculation, and we can see that it actually did cause it to go down. We included the 5.587 here, the 55 cents. $26 minus 55 cents divided by all the good pins means that the price now is $48,738.6. So let's look at this in summary again. We have this equation where we're trying to calculate the dollars per unit of the material costs. And in this particular case, we looked at revenue raw material, which is the cost of the entire 6-foot bar. That's what we wanted to do. That's how we were defining that particular raw material cost. We also looked at the number of good pins on average from this 6-foot bar stock. And then finally, we did look at the cost of recycling associated with this. So we included the amount of revenue we got for selling back the scrap metal. Now you can see here on the bottom too, so in all of this we defined a batch as the number of pins from one 6-foot bar stock, and that's how we were defining the pins. Okay, so that's how you calculate dollars per unit. In this particular case, we'll look at a couple other cases because it's actually not really a cookbook approach. We will use this particular equation often, but we'll look at other methods of doing that.